Assalamu alaikum rahmatullah. This is Fahad Hossain and I'm welcoming you all in Fahad's tutorial. And in this video, I'm going to explain the determination process of empirical formula from the percentage composition. And this is the videos which is actually linked with the concept of mole, and you know that all these videos is under the playlist of concept of mole. And in my previous video I was sequentially uploaded mole, the concept of mole, molar volume, molarity, and limiting reactant, and the percentage of yield. And in this video is all about the empirical formula, so the determination of empirical formula from the percentage composition. And I already uploaded a video on percentage composition, and I think you are familiar with these things, that if any percentage composition is given, then how we can get the empirical formula. So before going to explain it, we need to understand what is actually the empirical formula. Let's think about it. I hope you know about the molecular formula of benzene, which is about benzene is C6H6, okay? And of course ethine, we know it, C2H2, and also in case of glucose, you know it, which is C6H12O6. And of course you also know that in case of carbon dioxide. So I have written 4 molecules, and if you think that what is the percentage composition of it, we can find it out, because in the previous video I have already explained what is the percentage composition, how to find it out from the molecular mass, and I hope that you already know how to find out the percentage composition. Right now the question is, if the percentage composition is given like this, can we determine the empirical formula of the molecules? How? Think about this. And if I ask you the ratio of the number of atoms of different elements in these molecules, what would be your answer? The thing is that here carbon and hydrogen, what is the ratio of carbon and hydrogen? Is 6:6. It means 1 and 1. This is the ratio of the number of atoms of carbon and hydrogen in the benzene formula. So as it is benzene, we know that in benzene there are 6 carbon, 6 hydrogen, so it's all about 1 and 1. So the empirical formula of benzene is CH. Think about ethine, C2H2. Similarly, there is the same ratio of carbon and hydrogen, which is actually 1:1. So same, we have the empirical formula of ethine is CH. But here you see, this is the formula of glucose, and here the ratio of the number of atoms in different elements is 6:12:6. That means if you think, you'll have 1:1. So the empirical formula of glucose is CH2O, and here this is simply 1:2, which is no change. So the empirical formula of CO2 is CO2. But if it was like hydrogen peroxide, then you see that this is 2:2, so we can say this is 1:1, so this should be HO. So now if you think that what is actually the empirical formula? The empirical formula are showing the ratio of number of atoms of different elements in a molecule. So what is the empirical formula? That is showing the ratio is 1:1. It can be 8:8, it can be 12:12, or even it can be 2:2. Whatever, the ratio is 1:1 in case of benzene and in case of ethine. But you see, in case of glucose, it's 1:2:1. So we can have an idea the ratio of the number of atoms of elements in a compounds or in a molecule. So in glucose molecule, in one molecule of glucose, the ratio of carbon, hydrogen and oxygen is 1:2:1. That is the empirical formula. This is the empirical formula. This is the empirical formula of ethyne. This is the empirical formula of benzene. And from that concept, we can have another idea that one empirical formula can be same for different molecular formula, different molecules. See that CH and CH. Same. That means one empirical formula can be used in case of other molecular formula. But the molecular formula is always fixed for different compounds. So I hope you have the definition of the empirical formula. So what is the definition of empirical formula? Empirical formula is that which shows the ratio of number of atoms of elements, the number of atoms of elements in a molecule or in a compounds. Okay? So now if I just remove it, I want to show you something that what I've written in the right side of the whiteboard. You see there are some percentage composition is given. So if like this a percentage composition is given, can we find out the empirical formula? There are some steps and we have to follow these 3 steps. Number 1. The number 1 is, the steps number 1, I will not write, I'll just say that the number 1 is, what are the percentages given? We have to divide this percentage composition according to the relevant atomic mass. So we have to divide each percentage composition by their own atomic mass, not the number. So you have to divide it by the atomic mass. And then when you will divide the atomic mass, we will have a quotient. Among those quotient, we have to pick the smallest one. And then we need to again divide all this quotient by the smallest one, and we have to find an integer. And those integer will be used as a number of atoms of those elements, and then we will have the empirical formula. How? If, so I say that in a carbohydrate, the percentage composition of carbon and hydrogen is this. So if I say that in a carbohydrate, the percentage of carbon and hydrogen is this. Now you think that in carbohydrate there are also oxygen. So what is the percentage of oxygen? And of course the first thing is that you need to understand whenever you are trying to figure out the empirical formula, the percentage composition summation should be 100. And here you see this is only 40 and this is 6. So it is not the fulfill. So oxygen is actually there. So we need to find it out. What is the percentage of oxygen? As the clue is given, the question has said that in a carbohydrate, the percentage composition of carbon is 40%, hydrogen is 6.7%, and then what is the empirical formula? But you know that the summation is not 100, so it will be 100, so we can find it 100 minus 40 plus 6, 7. It will be like 46, so it will be like 53.33%, I guess. So I need a calculator. So I think 46.67, so if I divide minus 46.67, we got 53. Yeah, right. So now we got 3%. So according to my previous explanation, what we need to do first? Now we need to say that as carbon is given 40, hydrogen is given 6.67, and oxygen is given 53.33%. Now we need to divide each percentage by their own atomic mass. So the atomic mass of carbon is 12, atomic mass of hydrogen is 1, and atomic mass of oxygen is 16. Now you think, what is the percentage composition and what is the quotient? Now I need a calculator. So 40 divided by 12 is almost 3.33%. So 3.33%. Okay. 6.67, that would be 6.67%. And this is 1. Actually, we will not put this percentage mark. So 53.33. So 53.33 divided by 16 would be 3.33%. Now we think we got some quotient that we divided through this process and we got some quotient. Now we have to determine what is the smallest quotient among these. And we got 3.33 2 times, which is the smaller according to this. So now we need to divide all this quotient by the smallest one. So we got that carbon is 3.33 by 3.33, this hydrogen 6.67 by 3.33, this oxygen similarly by 3.33. So we divide all the quotient by the smallest one. Now you think this is 1, this is 2, this is 1. So we got an integer, actually 3 integers, and these integers are my expectations here, and these integers are the atoms number in case of finding the empirical formula of these compounds according to their percentage composition. So now we got it. So the empirical formula of these elements, of these compounds is CH2O. C1H2O. So we should not write C1O1. We will write only CH2O. That will be okay. So we would put 1 instead of here. So we just write CH2O. Okay? Think about it. Again, hydrogen, nitrogen and oxygen is given. Now I just think, is it actually, the percentage hydrogen, nitrogen and oxygen? In this case, we need to think about, it should be 22.22 if I am not wrong. Then yes, 22.22. So suppose it's given like hydrogen, nitrogen and oxygen. So now we need to find it out. Before going to explain it, I need to show you something here. H, S and O. Suppose here hydrogen, sulfur and oxygen is given. Now you think there are 3 elements. I'm just removing it. Okay? So you have to maintain the steps again. So I'm showing it again through this process. Suppose in the third one, okay, the percentage is given. Hydrogen is 11.13. Okay. So we need to divide it by the atomic mass of hydrogen, which is 1. Well, in case of sulfur is given 35.93. So I need to divide it by 32 as the atomic mass of sulfur is 32. And in case of oxygen, 62.92 given. So I need to divide it by 16. Now, what is the answer? What is the quotient actually? So the first one should be the same as it is 1, 1, 3, and it should be nearly 1. So 35.93 divided by 32, which is almost 1.12, 1.12, and here we got 62.92 divided by 16, which is actually 3.93. Okay, 3.93. Now I see the smallest quotient is about this one. So I need to divide this again, the smallest one, 11.13 by 1.12. 1.12 divided by, sorry, this should be the sulfur. Sulfur is given. So sulfur is 1.12 divided by 1.12, and again oxygen is 3.93 divided by 1.12. Now you think 11.13 divided by 1.12, which is actually 9.93. So if I am not wrong, I need to see it again. So 11.13 plus 35.95 plus 62.92. It's not right actually. I think I made a mistake. It should be 1.13. Yes, it should be 1.13. So it should be 1. Okay, and it should be again 1. And here 3.93 divided by 1.12 is 3.5. Okay, I was just making a mistake that it should be 1.13, but I was given 11.13. How I did find it? Because I just add all the percentage and I got 110%, which is not possible, so it would be 1.13. Now in this case, when you just divide by the atomic mass and you get again the fractions after dividing the smallest portion, then you need to do something. Then you need to multiply by something or any integer so that you can have the number which is not as a fractions. So what can I do? If I multiply by 2, multiply by 2, multiply by 2. This can be done. Then I will got here something in total integer, like this is 2, this is 2, and this is 7. Now I got an integer. Hydrogen 2, 2 and 7. No decimal, no fractions. Now I got an integer. So the empirical formula of these compounds is H2S2O7. And hopefully you know if this is the molecular formula, and this is about pyrosulfuric acid, or it's called oleum. Okay, I hope you got it. So now let's think about another thing, that if, okay, I'm just adding 1.58 plus 22.2 plus 76.19. It's okay. So now this is the pyrosulfuric acid, which is the empirical formula of this percentage composition. So I hope you understand how to do it. And again, if you see this example as hydrogen, nitrogen and oxygen, I'm just doing it here also, so it will be better. So hydrogen is 1.58, so I should divide it by 1, as the molecular mass of hydrogen is 1. In case of nitrogen, 22.2, so I should divide it by 14, as it's the molecular mass of nitrogen. And oxygen is 76.19 divided by 16. Let's do it. So it would be 1.58 and 22.2 divided by 14 is actually 1.58. So it is 1.58 and 76.19. So it would be 16, which is okay, 4.76. 4.76. Now I see the smallest one is this. So I need to write it that here. H2S2O7 would be the empirical formula of these equations. So it should be H2S2O7. Now you see that here hydrogen 1.58, I should divide it by the same. And in case of nitrogen, same, because it's about mathematics. And oxygen is 4.76 by 1.58. So this is 1, and what about this? 476 divided by 1.58 is about almost 3.01, so I can write 3. I should not write 3.01 because I will try to have an integer so that I can make it as an empirical formula. So that is why you got a number 1, 1 and 3. So the empirical formula of this percentage composition is HNO3, and this is about nitric acid. And this is the process of determining empirical formulas from the percentage compositions. And I hope those who are watching this video, this is very easy. I say that you just need to remember one thing. At least three things. Number one, the step is you have to divide the percentage composition by their own, the corresponding atomic mass. Number two, you have to find the quotient and then you have to divide it by the smallest quotient. And if you don't find any integer, and if you got any decimal or fractions, then you need to multiply by the nearest integer so that you can get the full numbers. And then you put it like as an empirical formula of that compounds. So I hope you understand this process. And the next step is how to determine the molecular formula from the empirical formula. And I'm coming up with this next video that how to fix the molecular formula from the empirical formula. See you in the next class, and of course keep watching these videos and do let me know that what is your requirements. I'm coming up with every day with your own adjustments, and please let me know that what is your demand in case of your study. Take care, stay well.